This video is for your quiz number 2. In this video, we are going to see how to do descriptive statistics using Microsoft Excel. We have already seen how to use TI-84 CE+ calculator to calculate all the descriptive statistics we need. But on the other hand, if I have a large data set, we cannot enter data points one by one into the calculator. Therefore, we need software. And our software is Microsoft Excel. So today, I'm going to show you how to calculate those familiar descriptive statistics using Microsoft Excel. In addition to that, we will also see how to draw a Box-Whisker plot for a set of quantitative data. Why do you need Box-Whisker plot? Especially if I have any outliers, they can be shown graphically using a Box-Whisker plot. Of course, Box-Whisker plot is the only graphical representation that allows us to show any outliers. Of course, to calculate the existence of outliers, we will need the third quartile and the first quartile. Those two are calculated using descriptive statistics. So that's a connection between the Box-Whisker plot and the descriptive statistics. So in this quiz, you will calculate descriptive statistics, and also you will draw a Box-Whisker plot. Let's go to Microsoft Excel. All right, so here you are on the Microsoft Excel spreadsheet, and I have a quantitative variable, weights in pounds, and it's a fairly large data set. If you scroll down, you can see it has about 3,000 data points. Okay, and then first I would like to calculate these descriptive statistics. So the popular descriptive statistics we need always are the summation, mean, also called average, true standard deviation, estimated standard deviation. So what are those two standard deviations? In your calculator, we have sigma x as the true standard deviation. Estimated standard deviation is Sx in your calculator. True variance and estimated variance. The variance calculations are not found as a part of the descriptive statistics given in your calculator. However, MS Excel has inbuilt functions to find those variances as well. True variance is sigma squared. Estimated variance is S squared. And then we can also calculate minimum for the data set, first quartile, the median, which is also equal to the second quartile, and then we can calculate the third quartile, and we can calculate maximum. Okay, so we will see how to calculate those descriptive statistics for this data set. There are so many different ways to calculate the descriptive statistics using Microsoft Excel. I will show you about 2 ways to calculate it. Okay, so some students often don't like to remember the functions, the commands necessary. So there's a shortcut for them. Select the cell where you need your answer, and then move your cursor to FX right here, and then click. You can select a category. At this point, I have set the category to all, or you can simply select statistical for most of the future calculations. But for the summation, we need all functions. Scroll down until you see the function summation. We are not seeing anything with complete word summation, but we have sum, S-U-M. That means I can obtain the summation of this data set using that function. Select that function, click on OK, and click on this little arrow. Select the first data point. I didn't include the variable label. I only selected the first data point. And with that, Shift Control down arrow key, that will select the entire data set. Now we have defined the set of numbers where I need the summation. Now I can move my cursor to this little arrow and click that, or I can simply hit enter. And then I don't have a second set of numbers, so the second field is kept blank. Simply click on OK. That will calculate the summation. Similarly, if I need to calculate mean, which is also called average, we can use that function. There must be a function for mean or the average. We will look for that function. So select the cell where you would like to have your answer, move your cursor to FX. Now you can actually change the category into statistical, because all these other functions can be found under statistical other than sum. What I need is the mean. Mean is also called average. So just pick one of those two words. Right here, the second function under statistical is average. So select that function, click on OK. And then just like earlier, I have to define the set of numbers. Click on this little arrow, select the first number, shift control down arrow key. That will select the entire data set. And then hit enter. There's no second set of numbers. Simply click on OK. So here's the average, 199.50. So likewise, we can calculate the other statistics as well. Now I need to calculate the true standard deviation. The correct word for the true standard deviation is actually not a statistic, but a parameter. Whenever you see the term true, that stands for a parameter. Anyways, that's trivial for now. Let's see how to calculate the true standard deviation. True standard deviation means Microsoft Excel assumes that the data set that we have entered is a complete data set for the entire population. So we need to tell Microsoft Excel to use the formula for the population. Whenever you see estimated, that means I need Microsoft Excel to think that the entered data set is just a sample subset of the population, not the entire population. So when you see the term true or the population, look for a function with some indication for a population or a parameter. They both start with P. Whenever you see estimated something, look for a sample statistics. Look for the function you need with some indication that it is for the sample. So true standard deviation. Let's see how to calculate true standard deviation. Select the cell where you need your answer. We can click on FX. The category is statistical. I can scroll down until I see standard deviation. So let's do that. Here we have standard deviation, stdev, but there are two functions. One is stdev.p, the other one is stdev.s. True standard deviation is what we need. True means for the entire population or the parameter. Clearly, that means I need to select the function stdev.p. Select that function, click on OK. Click on this little arrow, select the first cell, and then shift control down arrow key. That will select the entire data set and then hit enter. There's no second set of numbers, so the second field is kept blank. Simply click on OK. So that's how the true standard deviation can be calculated. Similarly, the next one is estimated standard deviation. That means I need to tell Microsoft Excel that this data set is a sample, not the entire data set from the population. So I need to select a function which also indicates that this is a sample. So here's a cell where I need the answer. I will move my cursor to FX. The category is statistical. I will scroll down until I see standard deviation. So here's the standard deviation again, but this time I need to select stdev.s because I need the estimated standard deviation or the standard deviation assuming the data set is just a sample only. Select that and then click on OK. And then the rest is very straightforward, just like earlier. Click on this little arrow, select the first data point, shift control down arrow key, hit enter, and then click on OK. That gives me the estimated standard deviation. Those two equations are slightly different. That's why we get two different answers. Of course, this is a very large data set having 3,000 data points. When you have a really large data set, the calculation for sample and calculation for population, they become pretty much the same. Only difference between those two equations is the divisor. For the calculation of the entire population, we divide by n, where n is the population size. For the calculation of the sample, we divide by n minus 1, where n is the sample size. So for this case, n is equal to 3,000. The answers are not going to be that different because 2,999 is very similar to 3,000. But on the other hand, let's say my sample size was just 10. In that case, whatever the numerator should be divided by 10 for the calculation of the population, and for the calculation of the sample, whatever the numerator will have to be divided by 9. So dividing by 10 and dividing by 9 are significantly different. In such cases where you have small samples, you will see visible differences between true parameter and estimated statistic. Okay, so the next one is the true variance. This time I need to find a function to calculate variance, and there has to be some indication where it is for the population, because it is for the true variance. Click on FX, category is statistical, scroll down until you see variance. So I have variance.p and variance.s. So select the function var.p for the true variance. Click on OK, and the rest is very straightforward, just like earlier. Click on this little arrow, select the first data point, shift control down arrow key, hit enter, and then hit enter again. That will calculate the true variance. Similarly, we can also calculate the estimated variance. Once again, select a function for variance calculation and with some indication for the sample. Estimated means for the sample. Go to FX, category is statistical, scroll down until you see variance. So right here we can see VAR, and this time I need to select var.s. Select that function, click on OK, and the rest is very straightforward. Click on this arrow, select the first data point, shift control down arrow key, and that's it. Hit enter again. That will calculate the estimated variance. Similarly, you can calculate the minimum. I need to find a function to calculate minimum. Select the cell where you need your answer. Click on FX. Category is statistical, and scroll down until you see the function min. Right here, I can see minimum. Min should stand for minimum. So I will click on OK. Select the set of numbers just like earlier. Hit enter and hit enter again, or simply click on OK. So the minimum is 164.77. And similarly, you can find maximum. Maximum, I need the answer right here for the last cell here. So I will need to find a function which will calculate maximum. Select the cell where you need your answer. Click on FX. Category is statistical. Scroll down until you see maximum. Here I can see a function max. Select that function, click on OK. Select the set of numbers just like earlier. The first number is selected, control shift down arrow key, hit enter, and then hit enter again. That's how the maximum is calculated. And also we would like to calculate the quartiles and the median. Let's see how to calculate the first quartile. So I will need a function that indicates quartile is what we are calculating. Remember, we have to define whether it is Q1, Q2, or Q3. So there will be two pieces of input. The set of numbers will be one piece of input. The other part of the input is which quartile it is, 1, 2, or 3. Well, we basically calculate Q1, Q2, Q3, where Q1 is the end point of the first quartile and the starting point of the second quartile. Q2 is the end point of the second quartile and the starting point of the third quartile. Q3 is the end point of the third quartile and the starting point of the fourth quartile. So we will see how to calculate the first quartile. I would like to have my answer right here for D12. So the cell D12 is selected. I will go to FX, click on FX. Category is statistical. I need to scroll down until I see some quartile function. I can see there are two functions to calculate quartile, quartile.exe and quartile.inc. You can pick whichever the function that you like. Just select one function randomly. So I'm going to select quartile.exe this time. Click on OK. Select the set of numbers for the first field right here. Click on this little arrow. Select the first data point, shift control down arrow key. That selected the complete data set. And then hit enter, or you can move your cursor back to this little arrow and click that. And then I need to define whether it is Q1, Q2, or Q3. So here I'm going to calculate Q1. So enter number 1 for that. And then click on OK. That's it. So the first quartile is 192.6156. Similarly, we can calculate the third quartile. So how do you calculate the third quartile? Once again, select the place where I need the answer. Move your cursor to FX, click on that. Category is statistical. Scroll down until we see the function for quartile calculation. So we have 2 functions. Pick whichever one you prefer. I selected quartile.exe, click on OK. Select the set of numbers as the first field. Click on this little arrow. Select the first data point, Shift Control down arrow key, hit Enter. And then you need to define the quartile number, whether it is Q1, Q2, or Q3. So this time I need Q3. So I will simply enter 3 for quart. And then click on OK. So here I calculated the third quartile, 206.4362. And then I need the median. Of course, there are 2 ways to calculate the median. One way is to use the function dedicated to calculate the median, which is the function median. Also, we can calculate it as Q2, quartile with quart equals 2. Anyways, I will simply use the function median. Select the cell where you need your answer. Click on FX. Statistical is the category, and scroll down until you see the function median. Right here, I can see median. Select that function, click on OK. Click on this little arrow. Select the first data point, Shift Control down arrow key, and then hit Enter. And that's basically all. The second field can be kept blank because I don't have a second set of numbers. Simply click on OK. So the median is 199.41. So of course, once these are calculated, we can also do calculations for the lower limit and upper limit, remember? That is to see if there are any outliers in this data set. So how do you calculate the lower limit? The lower limit is Q1 minus 1.5 times interquartile range, where interquartile range is Q3 minus Q1. The upper limit can also be calculated similarly. Upper limit is equal to Q3 plus 1.5 times interquartile range. Once again, interquartile range is Q3 minus Q1. We can calculate interquartile range using these calculated statistics. And the outliers are any data points that are smaller than the lower limit. They are called low outliers. And any data points that are larger than the upper limit are called high outliers. And if there are any outliers, they'll be shown in the Box-Whisker plot. So let's see how to draw a Box-Whisker plot. To draw a Box-Whisker plot, just like earlier, select the entire data set. In this case, we may include the variable label. So I have started from A8, and then Shift Control down arrow key will select the entire data set. Before drawing the Box-Whisker plot, it's better if you scroll up and go to the starting point. Once again, please make sure that you are not clicking anywhere on the body of the spreadsheet while scrolling up. If you do so, the selection will be gone. And if that happens, please make sure to select the entire data set before trying to draw the Box-Whisker plot. Okay, next we can draw the Box-Whisker plot. Select Insert right here. Click that. Select this one. Insert Statistic Chart. Click that. The first part is for histogram. The second part is for Box and Whisker. Simply click on Box and Whisker. So this is the Box and Whisker plot. So here is the upper limit, here is the lower limit. You can see some data points below the lower limit. That means there are low outliers in this data set. And if you need to copy this to a docx file, how do you have to do that? You can move your cursor onto the graph, right-click, simply copy that, and open a Word document, right-click, and then paste it there. Please make sure to convert your files into PDF before uploading on Canvas. And any other file formats, I may not be able to open, and if I cannot open, you will not get marks. So please make sure that all the submitted files are PDFs. All right, so that's it about this demonstration on Microsoft Excel for descriptive statistics and Box-Whisker plot. Now you can go ahead and answer your quiz number 2. All right, thanks.